Good afternoon. So today we look at the sampling distribution of the population proportion. Okay, so far we've looked at the sampling distribution of the mean, and we said some of the reasons why this is an important topic to study is because it helps us find the probabilities that a single sample mean will lie within a specified distance of its true but unknown population mean. So with our next chapter, when we're calculating confidence intervals, this sampling distribution is going to come in handy. And also when we're doing some hypothesis testing. So again, when we are looking at those, then you will see why this is actually a very handy tool to have. Now, today we look at the sampling distribution of the proportion. Now, proportion, we say we want to know how many out of a given number in the population described by a certain characteristic. So let's say, for example, if I'm talking about the class, we have male students, we have female students, I might be interested in what is the proportion of male students, what is the proportion of female students, okay? And the way that our sample proportion P is related to the population proportion pi is in the same way that X bar is related to mu, okay? Now, how do we calculate our sample proportion? We just say R divided by N. So remember, N is our sample size, okay? And then R, those are the cases that have the characteristic of interest. So if I have a sample from the big class, I pick a sample, then I would say in that sample that I've picked, if there's R of them that have the characteristic that I'm interested in, whether it is male or own a car or something like that, I would take that number and divide it by N, our sample size. Okay, so here is an example. It says in a survey of 883 Namibian adults, 380 say that their favorite sport is football. Find a point estimate. So if you remember, when we started, we said there's two ways that we can estimate our population parameter, either a point estimate, and a point estimate just means you're giving a single value. I estimate the mean to be 5. I estimate the mean to be 10 or something like that. That is a point estimate. And then another estimate that we give is what we call confidence intervals. And the way you would say that, I estimate the mean to be between 5 and 7.5. Or I estimate the mean to be between 8 and 17. And then you state how confident you are that the true mean lies in that interval. But here, finding a point estimate is very easy to do. So we took a survey. Remember, a survey refers to a sample. Otherwise, if it was the entire population, we would call it a census. So we have a survey of 883 Namibian adults, and this is our R, those out of the 883 who said they enjoy or their favorite sport is football. So as always, we need to write down the information that we are given. So N, this is equal to 883. And then our R, this is equal to 380. So to find the point estimate of the population proportion, we know we can use P. So sometimes we say P, sometimes we'll have a hat on top, P hat or P bar. This is equal to R over N. So we just see how many in our sample say they enjoy football. So it's 380. And this is divided by 883. So we can, of course, write our proportion in one of three ways. So the first way is you write it as a fraction in its simplest form. So you say 380 divided by 883. This is just that in its simplest form. So I cannot simplify it any further. So another way, of course, we can write it is as a decimal. So we can write it as 0.43. So this is the same as 0.43 if I write this to 2 decimal places. Or I can write this as a percentage. So on my calculator, I will just multiply by 100, and that will give me my percentage, 43.04%. So in a test, either of these is an acceptable way of writing it. So either as a fraction, as a decimal, or as a percentage, okay? And that is our point estimate. So a point estimate, like I was saying, it just gives you a single value that is an estimate for the parameter. But an interval, which is our next chapter, you will see that I give you a range of values and I say I'm 90 or I'm 95 or 99% confident that the true parameter lies in that interval. Okay, so these are examples of sample proportions. So for example, gender is one that you can use proportion to describe. So we look at proportion of females in the sample. Trade union membership, we look at the proportion of employees who are trade union members. Then mobile phone brand preferences. Then we look at the proportion of mobile phone users who prefer Nokia, or maybe who prefer Samsung, who prefer iPhones, and so on. So this is examples of the qualitative random variables that can be described using proportion. Okay, now this one is similar to what we did with our mean. What we should take away from here is that the sample proportion is also a random variable. So if you remember what we did when we were talking about the mean is if I have a population and then I collect different samples, and for each of those samples, I calculate their individual means, then you will see that I have a random variable of means. So the same thing is true over here. If there's a big population, from here I draw my first sample, and then here I work out the proportion. Then I get another sample. I work out its proportion there. Then I get another sample, I work out, so this is my P2, then I work out P3. You can see that each of these P's are different because the sample that I was picking was different. And these all give me a random variable. So the sample proportion is itself a random variable. Okay, now the mean of all sample proportions is equal to the true population mean. So these P1, P2, P3, and so on, if I were to take the average of them, then it will be equal to the population proportion. Okay, so the more of them I take, of course, then the closer the average of the sample proportions will be to the actual proportion from the population. And then the standard deviation of all sample proportions is a measure of the sampling error, and it is called the standard error of sample proportions. And this is how we calculate it. We have the square root of pi multiplied by 1 minus pi over n. So again, I said it might be a lot of statistical jargon, but the key thing to take away is that the sample proportion is an estimate for the mean, and then there are some equations, some formulas that we need to remember. Okay, so the histogram of all sample proportions is normally distributed. Again, remember, normally distributed just means it has a distribution like this. Very few in the extreme ends, very few in the extreme highs, and then most of them lie in the middle over here. So we say that the P is normally distributed. So this is the symbol, the tilde is the symbol we use to say it is the distribution. So it is normally distributed with a mean. So this first value here is our mean. The average of the proportions is equal to the population proportion. And this one here is the variance. So always remember, this is the variance. Okay, so it is always the mean, and then the second one is the variance. If you look at this one here, there was a square root, but when we square it, then you can see that the square root is gone because the standard deviation, this is our standard deviation. This is the standard deviation, and then this one is the variance. So if I have the standard deviation and I want to get the variance, I just square this one. And then the formula we use for transforming our P to a Z value is P minus pi over the square root of pi 1 minus pi over n. So if you remember, the one for the mean was Z is equal to X bar minus mu over sigma over the square root of n. So this one here was our standard error. But here, our standard error for proportion is this one over there. So everything else we do is pretty much the same way. If you understood what we did for the mean, then here, this one will be even easier. Okay, so the sampling distribution of the sample proportion. This relationship can now be used to derive probabilities, develop probability-based estimates, test hypothesis of the population proportion in statistical inferences. Okay, so a lot of these we will do in the chapters that follow. So I have a question here. Let me copy it. Okay, so here's the question. It says the Namibian poll found that for those Namibians who have lost weight, 31% believed the most effective strategy involved exercise. What is the probability that from a random sample of 300 Namibians, the sample proportion falls between 29% and 33%. So just like we did the one for the mean, first thing you must do is write down all the data that you are given. So here we're given this 31%. This comes from the Namibian population. So this is a population parameter and it's proportion. So we use pi. So we say pi is equal to 31%, but here with our calculations, you must either write it as a fraction or you write it as a decimal. Do not use it as a percentage. So I'm not going to write 31%. I'll either write 0.31 or I will say 31 over 100. So that's very important. In your calculations themselves, you must not use 31%. You must use either 0.31 or 31 over 100. And then it says, what is the probability that from a random sample of 300 Namibians? So we took a sample of 300 Namibians. So this means N is equal to 300. And we want to know what is the probability that the sample proportion. So the sample proportion, this one we call P hat or just P, is between 29%. Remember we said we don't write 29. We must write it as a decimal or as a fraction. So it's between 0.29 and 33%, but 33% we don't write it as a percentage, we write 0.33, or we write 33 over 100. And this is the probability that we are looking for. So first thing is you must write down all the information that you are given. Okay, then you write down what is the probability that you're looking for. Then the next thing is you need to standardize. So if you remember the standardizing formula, the transformation formula, Z is equal to P hat minus pi over the square root of pi multiplied by 1 minus pi. This is divided by n. So this is our formula. So we are going to transform this one, this one, this one, and then we have our answer from the table. So this is the probability. So I have 0.29 minus pi, which is minus 0.31. And this is divided by the square root of pi. So this is 0.31 multiplied by 1 minus 0.31. And this is divided by n, which is 300. And then here in the middle, we have p hat minus pi. This is divided by the square root of pi, 1 minus pi divided by n. And then we do the same thing on the right. So we have 0.33 minus 0.31 divided by the square root of 0.31, 1 minus 0.31 divided by 300. Okay, and then we close our brackets like so. Then these values we just work out on our calculator. So P, we take our calculators, and I'll start with this one. We have 0.29 minus 0.31 divided by big square root 0.31 multiplied by 1 minus 0.31. Close my brackets, divide by 300, and this gives us negative 0.75. Okay, and the reason why, even though here it has more decimal places, the reason why I only rounded off to 2 decimal places is because from the table itself, I can only round off to 2 decimal places. The table only gives 2 decimal places. And then this one here, this is our transformation. So here we have Z, and then over here, we work it out on our calculators. Just need to change this one. So this is 0.33 and everything else is the same. And I have 0.75. Okay, so this is the probability that I'm going to read from my table. The next thing is to draw your normal table and shade the area that you are looking for. So we have negative 0.75 here, and we have 0.75 here, and this is the shaded area that we are looking for. And we know from our table, let's take a look at our table. So this is our normal table. Then we can see the area that it gives us is the area on the right, on the left. So looking at what we are looking for, if we read 0.75, it'll give us the total area from here going all the way that way. And if we read the value of negative 0.75, it's going to give us this area here. So if we are only looking for this area here, we just need to say the value for this one minus the value for that one that we get from our table. Okay, so this probability is, we're going to start with the probability for 0.75. So we go to our table. So our table, we go down 0.75. So 0.701235. So this is 0.7734. Okay, and then we are going to subtract the other one. The other one, we look for negative 0.75. So the negatives are up here, negative 0.75. So this is a negative 0.7071, 2, 3, 4, and 5. So 0.2266, we write it here. And then on our calculators, we work this out. We have 0.7734 minus 0.2266. And this gives us 0.5468. Okay, then the last thing is always to just answer the question in a word format or in a sentence, because the question says, what is the probability that that from a random sample of 300 Namibians, the sample proportion falls between 29% and 33%. So the way you would answer this question, you would say the probability that this one here a random sample of 300 Namibians has a proportion between 29% and 33% is 0.5468. Okay, so this one here, you can write it as 54.68%, or you can write it as a fraction, 1,367 over 2,500. Okay, either one of them is fine. You don't have to write all of them, just one of them is fine. Okay, and that is how we answer it. And you can see that the way we do it is almost identical to what we did with the sample mean. Okay, here's another question. Let's try and do this one. It says, of the total 40 graduating honors student at NUST, only 6 are planning to proceed and do their master's studies. If you are to take a random sample of 20 graduating students, what is the probability that A, 17% or less of the graduating students will plan to do their master's, 20% or more will proceed to do their master's? So let's try this one. So we start with A. First thing is we must always write down our information. So this 40 here, this is the total because altogether there's 40 of them. So this is our big N. N is equal to 40. That's the total in the population. The graduates, there's 40 of them. Then it says that only 6 are planning to do their masters. So 6, this one we can call our big R. So this is 6. So remember the P hat, the formula was R over N. So here I'm just using big R to represent that this number comes from the population instead of small r, which comes from the sample. So now we need to work out pi. So here pi is not given, but we have enough information to work it out. So we can see that pi is equal to r over n, and this is equal to 6 over 40, which we can write in its simplest form. So 6 divided by 40. And this is 0.15. Okay, so now we have our pi. Then it says if we are to take a random sample of 20 graduating students, this means that our n, small n, is going to be equal to 20. So n is equal to 20. Now what we do is we start with the first one, the probability that 17% or less of the graduating students will proceed to do their masters. So it means we're looking for our sample proportion being less than or equal to 17%. Now remember we said we do not write it as a percentage. You must either write it as a fraction or you write it as a decimal. So you write 0.17. And this is the probability that we are looking for. So P hat. So we can sometimes we'll see I just write P. The hat doesn't actually matter, but that's one of the symbols that we use. So P hat is less than or equal to. We don't write 17 with the percentage sign. We either write it as 17 over 100 or we write 0.17. Then the next thing to do is to standardize. So we have P, the probability. Then we say P hat minus pi over the square root of pi 1 minus pi divided by n. Okay, and then we do the same thing on this side with 0.17 and we subtract pi. What is our pi? 0.15. And then we divide by 0.15 multiplied by 1 minus 0.15. And this is divided by our n, which is 20. Okay, so we have the probability. This one here is our z. This is less than or equal to. This one here we need to get from our calculator. So we have a big fraction here. 0.17 minus 0.15. This is divided by the big square root. 0.15 multiplied by 1 minus 0.15. Then this is divided by our sample size, which is 20. And this gives us 0.25. So 0.25. And we say the reason why we write it as decimals with only 2 places is because the table that we're given only reads 2 places. So now we draw a sketch of the area that we're looking for. So 0.25 is here. And because we're looking for less than, it means we're looking for all this area here. And we can see it's gonna be a little bit big, or maybe I drew it a little bit far away from 0, but it's more than 0.5 of the percentage. It's more than 0.5. Okay, next we go to our table. Okay, and then we look for 0.25. So here we have 0.1, 0.2, 0.20, 1, 2, 3, 4, 5. So this is our answer. So 0.5987. Okay, and then the last thing is to just answer the question. It says, what is the probability that 17% or less of the graduating students will plan to do a master's? Then we write the probability that 17% or less of the graduating students will plan or do plan to do their masters is 0.5987. Okay, that is our answer. Let's do the next one. B, again, we would do the same thing, but we don't need to work out pi again because we already have it. So pi is 0.15. And then what else did we work out? We took note that n is 20. Small n, this is 20. Now for B, we are asked to find the probability that 20% or more, so that means P hat is greater than or equal to, and remember we don't write 20 here, the 20% we must convert it to a decimal, which is 0.2. Then from there what we do is we standardize, so P hat minus pi over the square root of pi 1 minus pi divided by n. And then on this side, we do the same thing, 0.2 minus 0.15. And this is divided by the square root of 0.15 multiplied by 1 minus 0.15. And this is divided by 20. So we have the probability. This is our Z, and this is greater than or equal to. This one we do on our calculators. So everything else is the same. So I just need to change our first value here, and it is 0.2. So this is 0.63 when we round it off to 2 decimal places, 0.63. Okay, then you need to look at the area that you're looking for on your normal. So 0.63 is here, and the area that is greater than is this area over here. Okay, and looking at our normal graph, our normal table, it gives us the area on the left. And we know that the area from here to the end is 1. So if we're looking for the area from here to there, we just need to say 1 minus the value we read from the table. Okay, so like I was saying, the normal table that we are given is giving us this shaded area in red. We want the area in black. We know that red plus black, they equal 1. So if I want black, I must just say 1 minus the red, and this red here is the one I get from the table. Okay, so I want the one in black. So to get the one in black using the one in red, we just use our formula here. So this probability that Z is greater than or equal to 0.63, this is going to be 1 minus, I go to my table and I look for 0.63. So here is 0.60123. So it's 0.7357. 1 minus 0.7357. So go to our calculators. And this gives us 0.2643. Okay, so that is our probability. And then we write a sentence answering the question. We say that the probability that 20% or more of the graduating students will proceed to do their masters is 0.2643. Or of course you can write it as 26.43%. Here's another one. Introduction to Calculus is one of the gatekeeper courses at NUST. 63% of the NUST students are in favor of the removal of this course. A random sample of 300 students was selected and asked if they favor the move. What is the probability that more than 67% of the selected students favor the move? So again, we write down what we are given. So our pi, this is equal to 63%, but in our calculations, we write a decimal or we write a fraction. So this is our pi. And then this 300 here, this represents our n is equal to 300. Then we want the probability that p hat is greater than or equal to 67%, which is 0.67. So this is the probability that we are looking for. Then what we do is we are going to standardize. So this is the probability that p hat minus pi over the square root of pi, 1 minus pi over n. This is greater than or equal to 0.67. Our pi is 0.63. This is divided by the square root of 0.63 multiplied by 1 minus 0.63. And this is divided by n, which is 300. Okay, so we have the probability. This is our transformation. So this is just Z. And this one here, we work out on our calculator. Let's see what we get. Okay, and this gives us 1.43. Okay, then we draw our normal curve, and 1.43 is here. This is here. And the area that we are looking for is greater than, so it is this area over here. So it's on the right. Then you remember that on our table, the area that we are given is the area on the left. So we are given this red area here. And remember that red plus the black equals 1. So if we want the black is equal to 1 minus red. So this red, we read it from the table and then we subtract. So the probability, this is going to be equal to, we go to our table and we look for 1.43. So 1.40123. 1.43. So this one here. Okay. So we have 1 minus 0.9236, and this is going to be equal to 0.0764. Okay, then the last thing is to write a sentence. You can say something like the probability that more than 67% of the selected students favor the move is 0.0764, or you can say this is 7.64%. So here's one more. A random sample of 100 NUST students is taken from the population of all part-time NUST students, for which the overall proportion of females is 0.6. What is the probability that a sample proportion is less than or equal to 56%? Okay, so again, doesn't matter how the question is worded. First thing we do is we write down the information we are given. So we have this 100. This is from our random sample. So this is N. N is 100. Then we are given this 0.6. It says overall proportion. So overall is talking about the population. So we say pi is equal to 0.6. Okay, and what are we looking for? The probability that the sample proportion is less than. So the proportion p hat in the sample is less than or equal to 56%. And remember, we don't write it as 56%. We either write it as 0.56 or we write it as 56 over 100. This is the probability that we are looking for. Then the next thing is standardizing. So with the probability, we have p hat minus pi over the square root of pi, 1 minus pi over n, and this is less than or equal to 0.56 minus our pi, which is 0.6, and this is divided by the square root of 0.6 times, this is 0.4, 1 minus 0.6 is 0.4, and then we are dividing by 100. Okay, then this we work out on our calculator. This transformation is Z, so Z is less than or equal to 0.56 minus 0.6 over the square root of 0.6 times 0.4, or you can just still write it 1 minus 0.6, doesn't change anything. Then we have 100, and this is equal to negative 0.82 to 2 decimal places. So this is negative 0.82. Okay, then we draw the area that we're looking for. So negative 0.82 is here. So remember, 0 is always in the middle. So if it's negative, then it's on the left. And we're looking for less than, so it's this area over here. And that is exactly the area that we get from our table. So to get this probability here, we just need to read it from our table. So we go to our normal table and we look for negative 0.82. So negative 0.8012, this is the value. This is 0.2061. And then the last thing is to just write a sentence answering the question. We say that the probability that the sample proportion will be less than or equal to 56% is 0.2061, or you can write it as 20.61%, either one. You don't have to write both of them. You can write either one, or you write it as a fraction, okay? And that is everything on the sampling distribution for the sample proportion, okay?